Hello juniors. This video is going to be all about circles and properties that they have with their tangent line and radius. So if you're here to review for your MCA and you don't know much about these ideas, you're in the right place. So let's first start with just the definition of a circle. Hopefully we all know this, but let's define it anyway. A circle is the set of all points in a plane that are equidistant from a given point, and that given point is called the center. So equidistant means everything is the same distance away. Now, when we name circles, we name them for their center. So this, we can call it circle P, or its shorthand is literally a circle with a center in it, and P. So this is a circle if this point were called P. Now in there we have a couple other more specific things that we need to make sure we remember the difference of. So first is the radius. It's the distance from the center to a point on the circle, so center to the side, any part of it. And two circles are considered congruent if they have the same radius. Now a diameter is the distance across the circle through the center, so it's got to go through the center. That's a diameter. Please note that a diameter is twice the radius, because this would be one radius, this would be another, add it together, you get two. So let's talk about some other segments. The radius, the center, the diameter, those are ones we talk a lot about. Here's a couple more on here that maybe we don't talk about as often. So radius is again a segment whose endpoints are the center of a circle and a point of the circle, plural, is radii. So here, segment QP, segment QR, segment QS, those are all a radius of the circle. PS is not a radius because it does not start at the center. Now, a chord is a segment whose endpoints are the points on a circle. So as long as it starts and ends on the circle, it's a chord. So notice PS would actually be a chord. And actually, if you start at P and end at R, that's a chord as well. However, that's a more specific type of chord, which is the diameter. It's a chord, because it starts and ends on the circle, that passes through the center. So two ideas there of how to think about diameter. All right, two more definitions here. First is a secant. A secant is a line that intersects the circle in 2 points. So it's got to intersect it twice. So notice line J goes through the circle at 2 points. So line J would be a secant line of the circle. Now a tangent is a line in the plane of a circle that intersects the circle at exactly 1 point. So if a line only intersects the circle at 1 point, which would be right here, this line K is a tangent. So secant goes through twice, tangent touches just once. The point at which a tangent line intersects the circle to which it is tangent is called the point of tangency. So that 1 point where it crosses. So we have a couple of theorems, a couple of things we're going to need to know, and that is that if a line is tangent to a circle, so notice L is tangent because it only goes through point P. The cool thing is then we know that it's perpendicular to the radius drawn to that point of tangency. So QP is a radius, so we know we have perpendicular. What does perpendicular mean? 90-degree angle. So if we have a tangent and we have a radius, we know we have perpendicular lines. Next theorem, it says, in a plane, if a line is perpendicular to the radius of the circle at its endpoint on the circle, then that line is a tangent. So it's kind of the reverse. This time it says, if we're given it's perpendicular, then I could prove that that line is a tangent. Alright, so let's use these ideas. And the idea is, if we actually have a tangent, it should be perpendicular to the radius at that same point. So if we look, this says, is the segment CE a tangent to circle D? If it was tangent, it would truly only cross at 1 point, and that point would be E. And how we would be able to prove that is to show that it makes a right angle. Well, we don't know that right now. We have to be able to show it and decide whether or not that works. How do we know when we have a right angle? Well, that goes back to your Pythagorean theorem. If this is a right angle, and we don't know that yet, then we should know that a squared plus b squared should equal c squared. Let's remember from the Pythagorean theorem video that c is always across from the right angle. So what we want to do is to check, is a squared plus b squared equal to c squared? We want to know, is that true? If I can prove that it's true, then I can prove that that line is an actual tangent because it was perpendicular. So let's plug in our numbers. Is 11 squared plus 43 squared equal to 45 squared? That's what we want to know. That's what we're trying to find out. So 11 squared is 121 plus 43 squared, which is 1849. Does that equal 45 squared, which is 2025? We still want to know, is this true? And if we notice, when we add 121 plus 1849, we get 1970, which is definitely not equal to 2025. So the answer to the question, is CE tangent to the circle? My answer would be no. And my reasoning would be because CE is not perpendicular to the radius. Okay, so let's try another one. This word problem says that you are standing 14 feet from a water tower. The distance from you to a point of tangency on the tower is 28 feet. What is the radius of the tower? Notice this it did say point of tangency. When they give us that information, this time it's like the theorem where we are given the right angle. We know that it's true this time because it's a point of tangency. So what I'm going to do is to set up the Pythagorean theorem yet again. So we are going to use a squared plus b squared equals c squared to help us solve for the radius. Now, notice where the right angle is. The right angle is where the tangent line meets the radius. So across from the right angle is our c value. But notice, this whole thing has to be c. That whole side is the hypotenuse. And that whole side is not 14. That whole side is 14 plus r. So the trick to this one is using the right lengths. So a and b are our other sides. So if we take a squared, which in this case is going to be r squared, and combine that with b squared, which is 28, and set it equal to c squared, which is actually 14 plus r squared, we have to make sure that that goes in parentheses because we have to make sure we're squaring this full side. Okay, so let's do a little math here. R squared is, well, r squared, and 28 squared is 784, and that's going to equal 14 plus r squared. Well, 14 plus r squared is 14 plus r times 14 plus r. You can't forget the guts. You cannot forget the inside. It is not just 14 squared plus r squared. We're going to have some middle terms if you FOIL. So we're going to end up with r squared plus 784 equals, we're going to have to FOIL this out, 14 times 14, 14 times r. We're going to have to do that whole FOILing. So when we square 14, we get 196. And then 14 times r is 14r, r times 14 is 14r, and r times r is r squared. So if we go and then we simplify now, I'm going to have r squared plus 784 equals 196 plus 28r plus r squared. Alright, we have a whole lot of numbers here. So what we should do is to try to get all of our r's on the same side. So I'm going to move this one to the other side. Now if you notice, we're going to be left with 784 equals 196 plus 28r, and that's it because these ones also cancel off. The r squared and r squared cancel. So now if we subtract our 196, we're left with 28r equals 5 588. Okay, now if we divide by 28, we find out that r equals 21. So the radius of the circle is 21, or really 21 feet. Okay, hopefully that one went okay for you. Now, let's try a couple other theorems with this whole idea of tangent. This one says if two segments from the same exterior point are tangent to a circle, meaning they cross somewhere. So we have two tangent lines. This is a tangent line and this is a tangent line, and they have a common point. What we find out is they're actually going to be congruent from that point to the point of tangency. So S to R is going to be the same length as S to T. Okay, let's try using that. This one says segment AB is tangent to circle C at point B, and segment AD is tangent to circle C at point D. Find the value of X. So what we know is these two are both tangent and they share a common point on the exterior, and therefore the length of AB is equal to the length of AD. So we know that those are congruent. So what we can do is set them equal to each other. X squared minus 4 should be the same thing as 21. So if we go ahead and solve here, we're going to have to add 4 to both sides. And we get x squared equals 25. And now the only way to solve for x is to square root. So x equals 5. And it simply wanted the value of x, and the value of x is 5. Now, that is all we have for circles and their properties, including tangents and their radius. Hopefully you learned a whole lot, and we'll see you next time.